All right, so this is 7.1, Areas of Parallelograms. Please go ahead and set up your page up at the top, and please write down the definition of a polygon. So a polygon is a closed figure in a plane that is made up of 3 or more line segments that intersect only at their endpoints. The area of a polygon is the amount of surface it covers, and you can find the area of a parallelogram in much the same way as you can find the area of a rectangle. Our key idea is the area of a parallelogram. In words, it means the area A of a parallelogram is the product of its base B and its height H. A couple things to note is that when we're dealing with area of something, we always use a capital A to recognize area, even though it's still a variable because that's something that we're finding. And then when we use base, we use a small or a lowercase b. Same thing with height, a small or a lowercase h. Algebraically, it is A equals B times H. And it would be written just like that. Go ahead and take a minute to sketch this parallelogram out. And then please label it just like I have here. So you have your line that comes down here. It almost makes like a chair or the letter H in a way. What this is signifying is that this is a right angle or 90 degrees. And this is showing from the base to base. So this line here on the parallelogram is a base. This is also a base. It's really important to know that the base of a parallelogram does not have to be horizontal. This shape could actually be flipped up on its edge, and this could be up at the top, and this could be at the bottom. That doesn't make it its base. The base are the two parallel lines that run parallel to each other and can be on any side of the actual shape. I'll show you a few of those examples in a moment. So now we have area equals base times height, where this is our base and this is our height. Let's do a couple practice problems. Example 1 is finding areas of parallelograms. Here we have 2 practice problems. We're going to start with A. We have a parallelogram, and as you can see, you've got your line that comes down here that makes our right angle. This is representing, this red line is representing 14 meters, and down here is representing 12 meters. So you'll notice that when the line of height runs and it intersects into the base, that's where we can find our base. So our base happens to be 12 meters and our height happens to be 14 meters. So we're going to write it out like this. You start with your formula. Area equals base times height. The next thing you do is just like algebra, you start plugging in. I know right now that this is my height and this is my base. So I go down to the next one and I do area equals, this time I fill in my base. My base is 12 and I put it in parentheses, times whatever my height is. My height happens to be 14, so I put that in parentheses. You could also put the dot in between them, but I do recommend that you put them into parentheses so you know the difference. Anytime there's 2 parentheses next to each other, we know that it's multiplication. Then we just simply solve. 12 times 14 happens to be 168, and then that is what our A equals. Then we just need to make sure we understand that we're talking about area. So when we talk about area, we always make it squared. So it would be 168 meters squared. This would be my answer, and you just put a circle around it. You'll notice how similar this is to finding a rectangle, because a rectangle is length times width. So let's work on B. We've got A equals base times height. Always write out what the formula is. That's your first step. Then the next one, you put your next A down, but we fill in what our base and our height is. So our base on this one, they show it up here at the top. So this happens to be your base, even though it looks like it on the other one, it was on the bottom. That's okay, it can be labeled on the top. And you'll notice that this line, our height, comes off of the parallelogram a little bit. And that's just because they could have put it right here if they wanted to, but it kind of makes it cleaned up a little bit. So if you ever see one out like that, it doesn't matter. It's still what our height is, which is 8.5. So now our base is 4. We multiply that by our height, and our height is 8 1/2. Now we just do 4 times 8.5, and you could do a little side math if you needed to, but the answer would be 34, and this one happens to be feet, and it's also squared. If you forget the squared, it's incorrect because we're talking about area. All right, here's a few try it problems. I want you to try these on your paper, and then once you're finished, you go ahead and pause it. Once you're finished, then the answers will be there. All right, for number 1, the answer is A equals 500 meters squared. Number 2, area equals 126 inches squared. And number 3, I just wanted to point out something. When you did the base, so here's my base, although it looks like it's on this angle, it's not. You need to look at where it shows you the right angle sign, and this would actually become your base. So 30 times 20.5. Now you might say, it doesn't matter which way we do it because we're going to get the same answer, which is correct. But once we start looking into other formulas, it might make a difference. So you need to make sure you're on the right track. When finding areas, you may need to convert square units. So the diagram to the left shows that there are 9 square feet per square yard. So think about, this is 1 yard and this is 1 yard. It's a square yard. 1 times 1, well, is 1 square yard. So this whole area is 1 square yard. However, when I convert it to feet, each of these little units is represented by feet. So that means there's 1, 2, 3 feet by 1, 2, 3 feet. Well, 3 times 3, to find the square units of this, would be 9 feet squared. So you'll see that there's 9 little squares in there. You can use a similar procedure to convert other square units like we'll show in example 2. Make sure you've written this down and we'll do example 2. Example 2 is finding the area of a parallelogram. And what you'll notice is that the beginning of this says find the area of the parallelogram in square inches. They give us the area or the dimensions over here in feet. So we're going to have to do a little converting in just a moment. And that's where all of this information is going to kind of come in handy. So we're going to start off with writing area equals base times height. Then we're just going to simply do all the steps that we did before. Our base on this would be this line here because it's where this intersects. So it will be 2.5. And then our height is 2. Now remind you, these are all in feet. So I'm going to solve this. 2.5 times 2 equals 5. So we know that the area is 5 feet squared. However, they want us to do it in square inches, so we need to do a little conversion. I'd like you to write this information out. So it says the area of the parallelogram is 5 square feet. That's what we determined down here. To convert the area to square inches, use a conversion factor. So we're going to notice that 1 foot squared equals 1 times 1 foot, right? That would equal, if we know that there's 12 inches in 1 foot, then that means 12 times 12 would equal 144 inches squared. So now if I have 144 inches squared and I have 5 feet, oops, that's a bad 5. And I have 5 feet squared and I multiply that by 144 inches squared, I should come up with my answer. Now, this is an easy way to look at it, but I do want you to understand, in order for us to get from our feet and get to inches, we do need to look at it like this. If I have 1 foot squared here, and we cross those out because we're cross factoring them, that can get rid of my feet, and now I have 5 times 144 inches squared ends up equaling 720 inches squared. And that would be the total area of my parallelogram in inches. The final example is example 3, modeling real life. I would like you to take and write out this question right here. It says the area of a parallelogram shaped forest bordered by roads is 99,000 square yards. What is the length of the deer trail? So you have to notice in here, you have to find and locate where the deer trail is, and it happens to be right here on the picture. So that's what our focus is going to be. What is the length of the deer trail? There's a few things to note in here. We have to note that we have 99,000 square yards is our complete area. So I'm going to set up my formula for a parallelogram because that's what shape I'm given. So I have area equals base times height. Now we start plugging in, just like we did in algebra, what we have and what we don't have. So we have to understand that we have the area because it tells us in the word problem. So I'm going to do 99,000 equals, because that's my area. Now I have to figure out what I have. I've got this line right here that's signifying my base because I can see that my line intercepts here with my 90-degree angle. And so my base is 660 yards. So 660 times my height. Well, the height is what I'm trying to figure out. That's that deer trail. So I'm just going to leave it at h because I don't know what it is. Now we will go back to algebra and remember, how do I get my variable all by itself? Well, I've got h that I'm working with right here. So I want to get that all by itself. In order to do that, I have to recognize that it's 660 times h. So when I have multiplication, I do the inverse operation and I divide it. So I'm going to divide out, that's a terrible 6. Oh my goodness. I'm going to divide out 660. 660 divided by 660 gives me 1. So that leaves me with h. Now again, if I'm going to divide it over on this side of the equation, I have to do it over on this side of the equation as well. So now I will divide out 660 on the other side. So I have 99,000 divided by 660. And I'm just going to do a little bit of long math here and figure this out. So I'm going to go ahead and click that on. I want you to fill this out as well because it is a little bit of a longer problem. So in working this out, 99,000 divided by 660 ends up being 150. So I can clear out my zeros there. So that means my height should be 150. Now I want to make sure that this makes sense. If this line right here over to the right is showing that it's 660 yards, would that make sense that my height would be a shorter distance of just 150 yards? Yeah, it's a lot smaller of a space. So the answer is, what is the length of the deer trail? You would answer it like this, 150 yards. Would it be yards squared? No, because it's not the area. We already had the area. Now we're just figuring out how long just that trail is. And this concludes our 7.1 video.